I'm Clark Nicholson, Program Manager with the Remote Desktop Services team at Microsoft. And I'm here with my colleague, Pavitra Thiruvengadam today. And we're going to be talking about our new next generation remote desktop services that we refer to as the modern infrastructure. Before I get started, though, I always like to do a little survey. How many people in the room have deployed our full remote desktop services suite, including the brokers? If you could raise your hand. Oh, that's good. Looks like probably about 90%. And how many of you have deployed anything in Azure IaaS, VMs, and so forth? All right, looks like about half the room. And how many of you have deployed remote desktop services in Azure? Oh, that's pretty good, about a third of the room, I'd say. So before we get going and dive into the modern infrastructure, I think it would be fitting to talk about our vision for the future. Because I think once you see where our destination is, you'll see that the modern infrastructure is the next step in that journey. So in a word, our vision is Azure. We think Azure is the platform for all kinds of Windows desktop and application virtualization, whether it be RDS or using one of our partner platforms. All right? The reason we think Azure is such a fantastic platform for us and our workloads is firstly because we get this fantastic secure identity system, Azure Active Directory, that provides us with all kinds of security features like conditional access, where we control which users can log in from which geographies in the world or from what apps and what devices. We can set up multi-factor auth, right? So they have to get a phone call or an email or something in addition to logging in with their usernames and passwords. And we can start taking advantage of some of the real advanced features like intelligent security graphs. Now we also get elasticity of Azure, which is super important for our workloads. Because we know in the middle of the night and on the weekends, generally speaking, there aren't a whole lot of users using the virtualized Windows desktops and applications. And then starting in the mornings, things start ramping up. And so the dynamic range of our resource utilization with this workload is very significant. Could be 1,000 times from the smallest times of the day to the maximum times of the day. And with Azure, we get to take advantage of this amazing elasticity that's built into Azure's public cloud. Now, we also get these abstraction layers that significantly simplify the management of our deployments. So first, there's infrastructure as a service, where Azure has essentially abstracted away all of the physical compute, networking, and storage technology, right? So we don't have to manage physical servers anymore. We get to work in a virtual level. Virtual machines, virtual networking, virtual storage. But there's also the PaaS infrastructure up there. That's another layer of abstraction even above that, right? Where we get to provide a web service package to the PaaS environment, and underneath the hood, they will take care of all of that virtual computing infrastructure. They'll build the virtual machines, the virtual networks, set up the load balancers, scale for us. And we don't have to do that. We just have some knobs that we get to twiddle to set that up. So between these two, we can significantly reduce the cost of deploying and managing these virtualized environments for Windows. And lastly, we have this amazing global footprint we get to take advantage of, right? Data centers are springing up all over the world. So we can provide the desktops and applications from a data center that's nearby our users, anywhere on the planet. So we can provide a good experience no matter where our users are. Now, I want to say that Azure, and by extension Azure Stack, is where we're optimizing because that is our North Star. That's where we see Windows virtualization going. But that doesn't mean that we're not supporting on-prem, right? Everything we do will also be possible to do on premises, okay? Just wanted to make that clear because we've had a lot of conversations about this and people do get confused there, okay? So I'm going to take you now back in time a little bit to the beginning of this journey. It's always fun to do a little journey down memory lane. Back in 2013, when infrastructure as a service was first introduced on Azure, we started working with some of our customers, deploying what at that time was Server 2012 R2 to deploy RDS in Azure. And after a while, we had some work to do. We actually had to make some changes we had to ask for some changes from some of the Azure teams and so forth to get the workload to really run very well, but we got there. Put out some documentation, and really that was the beginning. People took off and started doing this. But we realized after that experience that we weren't really fully taking advantage of Azure. We'd done this kind of simple lift and shift, which is really where a lot of folks start from, right? But we weren't really taking advantage of all of Azure's capabilities. And so one of the big things was the platform as a service features that were already in Azure, that what we call first-party PaaS, right? These are the services that Microsoft teams have already built. So for example, we had customers saying, I don't get it. When I spin up an HA broker, why do I have to spin up a SQL Server cluster in VMs? Why can't I use Azure SQL DB, the PaaS service? It's significantly simpler to set up, much lower cost. Well, as it turned out, it didn't work, and we had some work to do. We had to make some changes in our code, and we had to go to the Azure SQL DB team and ask them to make some changes as well. And then people were asking us the same with Active Directory. Why do I have to spin up Active Directory in VMs and set up a sync with Azure Active Directory? Why can't there be a service that just provides Active Directory functionality, the traditional classic Kerberos-based Active Directory as a service? So again, we went to our friends over on the Azure Active Directory team and started working with them. And so last year at Ignite in 2016, we announced RDS 2016 in Azure and some of the improvements we made. And most significantly, we are now able to take advantage of, for example, of Azure SQL DB as our database for an HA connection broker cluster. And this was huge. If you know the cost and the complexity of setting up a SQL Server cluster versus checking a few boxes up in Azure and saying, give me a SQL Server database, please, it's stunningly simple. And we also, in fact, just this recently, we've now got our Azure Active Directory domain services running on ARM. And if you saw a session this week on that, I suspect. So these are a couple of announcements we made at last Ignite. Now, I want to walk, for the folks in the room who aren't terribly familiar with RDS as the full stack, I want to walk you through a connection flow here real quickly so you see how all of these components are used in a virtualized Windows desktop and application deployment, right? So first of all, the user will start from one of our clients, either running on Windows, Mac, or iOS, or Android. They'll connect to our RD Web. So they'll either go to the RD Web site, or they'll subscribe to the feed. And in order to do that, they have to authenticate. They have to prove who they are. And they'll authenticate against Active Directory in the back end. This is important. They're not authenticating actually against Azure Active Directory, but Active Directory. In this case, it's an Active Directory domain services instance that's been built from Azure Active Directory, but it has to be the classic Active Directory. And that's because of where RDS came from, right? It came from an enterprise environment where everything was Active Directory, right? So once they've authenticated, the RD Web will ask the broker, what resources is this user authorized to access? And at this point, icons will start showing up in the UI of remote apps and desktops that the administrator has published for this user. When the user selects one of those resources, they'll be connected up through our secure gateway. The gateway will talk to the broker and say, okay, I've got a user, needs to connect to this resource. Can you tell me, can you please route this person to the appropriate session host server in the back end? And the broker does that, and off we go. Now the user has a connection end-to-end from the client all the way back to the session host, and they can start doing their work. Now, I want to make a couple of key points here. 1 and 4, those two arrows, those connections, those are not, especially 4, people get confused about this and think that's a 3389 RDP connection. It's not. It's 443 HTTPS connection. Both of these are. So this is a secure environment that we have. These are encrypted connections, and we only turn it into RDP on the other side of this. And that's why the back end of this deployment, the broker and all the session host servers, those have no public IP addresses. Right? They're secured behind the RD Web and gateway. So some additional improvements that we've made since Ignite last year is we've introduced an HTML5 client now. It's in private preview now, be coming out in public preview soon. We'll probably GA in the spring. And what this allows you to do is deploy this HTML5 client on the RD Web instance as another site there, so that now users can connect from any device that has an HTML5 browser without having to install a client. So this opens up, scenarios like the airport kiosk, right? Where they can still get to their desktops and apps, even from devices that they don't own. Now, another thing that we added is support for our virtualization host to support VDI. We do this using Azure's new feature of what they call nested virtualization, which allows a VM in Azure to have Hyper-V enabled. And then we can use that Hyper-V VM as our virtualization host and install our host agent, we call it, right? And now we can support Win10 deployed on Azure in the VMs on that virtualization host, right? And recently, the licensing has been opened up to allow this scenario for enterprise customers, right? So this is all the stuff that we've got essentially in market today. This is kind of state of the art, right, with RDS. So over the last year or so, the team has gone back and said, okay, what can we do next, right? How can we take this even further? And one of the key things that we wanted to do was, again, take advantage of the stuff that's in Azure. We want to take advantage of much of that as we possibly can to make it easier to deploy and simpler to manage these things. So we came up with this architecture. Okay, the first thing you'll notice here is that what we call the RD infrastructure components, RD Web, Gateway, and Broker, these have been refactored as .NET Core Web Services. And what that means is that they can be deployed in Azure as Azure App Services, which is part of the PaaS infrastructure. And as I said earlier, that means I don't have to, as an admin, stand up a bunch of VMs and VNets and load balancers and scaling programs, right? All of that's taken care of for me now by the PaaS environment that's in Azure. You'll also notice that the virtualization host has gone away. So we've eliminated this component out of our suite of components. And we've introduced an agent that runs at the guest level now. That's the little A circles on the desktop session host. Okay, so now the agents can talk directly to the broker and vice versa. So we don't need that host agent any longer running on the virtualization host. This flattens the whole deployment down, right? Everything's at the guest level now. We've also introduced a diagnostic service. So this is a new service that we didn't have before. So part of the feedback we've gotten over the years working with customers is how difficult it is to troubleshoot problems, kind of end-to-end connection problems and so forth. Because every service was logging events independently, and you'd have to go through and look at timestamps and try to figure out how this all tied together. Well, now we have a diagnostic service where all the different roles, including our clients and both endpoints, can be correlated. The event it starts from a user interaction with the system, and we can set up a correlation ID, and all the events through the system get associated with that. So now it's very easy to see what happened with a specific action, whether that be a user connecting or whether it be an admin interacting with the system. This significantly simplifies the troubleshooting of these types of end-to-end problems that you can run into in these virtualized environments. And finally, you'll see that the user profile disks in this architecture are stored on the PaaS service Azure Files. So this is a new version of Azure Files that will be available soon. You'll be able to use Active Directory ACLs, so the classic Active Directory ACLs, to set up your share and control access to it, which is basically what RDS needs, and frankly, it's what lots of applications need that have been developed over the past 15 years. They've all depended on Active Directory ACLs. So this is work that we're doing in conjunction with the Azure Files team. They had a session earlier in the week where they said that they talked about this and that they're working on this. So that's a collaboration between our teams, right? But the key here is at this point, when this architecture is completed, the only virtual machines now in this system are in the dark blue box. They're the actual virtual machines that are running the session host and the Win10 VMs where the users are logging in and the applications are running. Those are the VMs. Everything else around that is a PaaS service now. All right, yeah, I heard a smattering of applause back there. So at this point, I'm going to take a break. I'm going to invite Pavitra up, and she's going to walk you through a quick demo comparing a 2016 deployment in IaaS versus one of our new modern infrastructure deployments in PaaS.
Hi, I'm Pavitra, and I'm also a program manager in Remote Desktop Services team. And I'm going to show you how fundamentally different an RDS 2016 deployment on Azure looks compared to RDMI, the RDS Modern Infrastructure deployment on Azure would look, and what entities will be part of each of these resource groups. So I have, of course, several resource groups here, but we'll be concentrating on two resource groups, one associated with the RDS 2016 deployment on Azure, and another one with RDMI deployment. So if you open the resource group concerned with the RDS 2016 deployment and sorted by type, so it's easy for you to see what I want to show, you will see a bunch of virtual machines here. Some of these virtual machines are just RD session hosts that will be running the workloads for the remote apps and the remote desktops. And the others are the actual RDS roles. This will be the connection broker, the gateway, and the web in this case. This particular deployment has been set up with high availability, so you will have at least in this case, we have 2 connection brokers, 2 web access roles, and 1 gateway. When you have high availability set up alongside with VMs, you need to also have load balancing set up so that the load will be balanced across the multiple instances. So we have a load balance setup for connection broker, and we have a load balance setup for web. Now, if the admin wants to cut costs during off hours and he wants to reduce the instances for connection broker and web access, you also need to have some kind of algorithm or a script that will look at the hours and make sure that these instances are shut down, and when it's peak hours, the instances are brought back up. And so the admin here has got some scripts that will do exactly that, scale in and scale out of these connection broker and web access rules. And these are all VMs alongside these extra entities for RDS 2016. By contrast, if you look at the resource group associated with the RDS modern infrastructure deployment on Azure, the first thing that you will notice is that there are no virtual machines here. There are absolutely no virtual machines. When the deployment finishes, the only things that will be in the resource group are app services. So these are running your RDS infrastructure roles, the broker, the diagnostics, the gateway, and the web access. And these are just web apps that are installed on top of the PaaS services, which is the app service. Apart from the actual app service, you have some service plans that can be configured to support these app service. And then you have a key vault that the deployment will use for certificates and secrets so that it can function properly. And then you have the SQL database that the connection broker will use for user management and VM management. If you look at the Gateway's app service plan, this essentially gives you all the configuration needed to manage and set up the actual app service that is running the Gateway service. And there are a bunch of features that app service offers, and one such feature that the admin can leverage for RDS deployments is the scale out and the scale in feature. So in the traditional RDS 2016 deployment on Azure, we saw that there was a load balancer, and apart from the load balancer, you also had scripts that were scaling in and scaling out these instances for connection broker and web access. Here you have none of those things. The load balancing is taken care of by Azure automatically for the Gateway app service, and the only thing that the admin has to set up initially is the rules related to scale out and scale in. For the demo, I've got 2 rules set up here. One is the scale out condition, and what I have set up here is when the CPU percentage of the gateway instance is greater than 3% and it's consistently so for 5 minutes, you increase the instance count by 1. And the maximum instance count that I've got set up is 5 because you don't want to go beyond that. And I've set it up for 3 so that it's easier for me to demo, but in production environment, this will be closer to around 70% so that you don't max out the gateway instance. And the scale in rule that I have got is when the CPU percentage is lesser than 1% for consistently for 5 minutes, then decrease the count of instance to 1 by 1, and the minimum that we have got set is 1 instance, so you will never run out of instances and the gateway will never be down. And so this is all the admin has to do to set up the scale in and scale out. There is no extra scripts that they need to do. They don't need to do any of the other management that comes with VM management too. And if you look at history, we simulated some loads over the past few days so that we can show you the scale out, scale in. So you started with 1 instance, and after a little load, quite a lot of load, we increased to 3 instances. And then this was consistent for a while because we were doing some testing, and you can see that after a while we were happy with the environment. And so there was no traffic and it just dropped down to 1. And this all happened automatically. We didn't have to write any scripts. We didn't have to do any load balancing between these instances, none of those things. The only thing that the admin might have to do on a day-to-day is probably monitoring, and that also comes alongside with the alerts feature in the app service. So you can see how fundamentally different RDS 2016 deployment is compared to the RDMI deployment on Azure. Hand it over to Clark.
All right. Thank you, Pavitra. So yeah, I think you can see that this is a pretty significant step forward now, being able to use these Azure App Services for our infrastructure. So another key thing I want to draw your attention to then in this new architecture is the fact that we're actually using Azure Active Directory for our initial authentication, not Active Directory. So with the modern infrastructure, the clients will actually be authenticating against Azure Active Directory. And this is the thing that now allows us to take advantage of all of these great security features that are being built into Azure Active Directory, additional access, multi-factor auth, and so forth. So at this point, I'm going to take you through the connection flow with the modern infrastructure so that you kind of see how this compares to RDS 2016 deployment that we walked through earlier. So first of all, it's important to note that there's a persistent connection. Before the user ever starts to log in, every agent has a connection out to the broker, and it's being used for signaling. Right? So there's a heartbeat coming from the session hosts or the Win10 VM instances, and it's a WebSocket connection that's been initiated by the agent. But once it gets established, it's a bidirectional connection. So the broker can talk to the agent, and the agent can talk to the broker over that connection. So that's sitting there from all the different session hosts when the user logs in. The user will come into RDWeb to try to access the feed. They'll get redirected to Azure AD. They'll have to authenticate. And if their admin is set up, conditional access, et cetera, they'll have to pass all those tests. And eventually, they'll get a token back. And they'll present that token will be presented back to the RDWeb to get the feed of the resources. Okay, then the RDWeb will talk to the broker, find out what resources this user is authorized to access. And just as in 2016, at this point, the user interface in front of the user will now show all the icons of the apps and desktops that they've been authorized to access. If they connect on one of those, select one of those, they'll connect to the gateway. The gateway will talk to the broker, and the broker will now decide which session host this user should be connected to, right? That's the load balancing it does. And then it does what's called orchestration. So it'll go out to that session host and say, will you please connect to this gateway so this user can get access to you? And the session host will then connect up to that same gateway. Now, it's important to note that, again, 1, 2, and 4, those are all secure, encrypted connections coming into the modern infrastructure over HTTPS. Now, the interesting thing I want to draw your attention to is the fact that the connections from the agent back to the infrastructure are what we refer to as a reverse connect. So they're initiated by the agent. So they're outbound to a 443 port in the infrastructure, both for the signaling channel and also for the RDP channel. And so the RDP channel and the signaling channel will be connecting from the agent back to the infrastructure, and that connection is initiated by the agent. And what that means is we can secure the tenant, what we call the tenant environment or the session host environment, completely lock it down. It has no inbound ports open on its network security group. Only thing it needs is an outbound 443. So now we've completely isolated the user's world, essentially. They're where they're running their apps, where their data is located, and so forth, right? Now, another feature that we're implementing is what we call multi-tenancy. So you'll notice that the infrastructure is no longer joined into the same domain as the session hosts. They're in a different domain. In fact, they're not in an Active Directory domain. They're only associated with the Azure Active Directory under which the subscription they've been built in, right? And the session host environment can have its own Azure Active Directory, and there can be multiple session host environments, each with its own Azure Active Directory. So every one of these session host environments, one infrastructure can support many of these session host environments, and all of them can be in different, underneath different Azure Active Directories. Now, this also allows us, because they're completely isolated from each other, these different session host environments can have different configurations for Active Directory, right? So the one on the top I've shown here with Azure Active Directory Domain Services as its domain controller. And I've shown it with UPDs being stored in Azure files. But the one below has a classic Active Directory deployed in a VM and UPDs on a file server. And what's further is, because these are completely isolated from each other and the rest of the world, it's very simple and secure to set up a VPN connection back to a corporate network. The corporate security guys don't have to be concerned here because there are no inbound ports on that session host environment. Okay, so I'm going to step back and let Pavitra show you a demonstration then of how we've built these isolated tenant environments, and also show you an example of multi-factor authentication.
Thank you. So when we looked earlier at the dashboard for the RDMI infrastructure, I was signed on to an Azure subscription, which was different. The username is different. The admin is different. Now we are going to be looking at an Azure subscription which has all the VMs that's going to be running your workloads, which is the remote app and the remote desktops. It has all the users associated with this particular tenant who are going to be accessing the remote desktops and the remote apps. And this particular subscription is completely different. It's in a different Azure tenant ID, and it has its own set of admins and users. And I have logged into this particular different Azure subscription. So here I have set up a resource group that contains virtual machines that will be running the workloads for this RDMI infrastructure. And the virtual machines that I have got set up here are different kinds of RDSH, which will be 2012 R2. So Windows Server 2012 R2 running RDSH. I have 2 RDSH running on Windows Server 2016, and I have a plain Win10 VM. If you notice, I don't have any kind of RDVH here, and so it's just the Win10 VM sitting there. As Clark mentioned earlier, we will be having an agent residing on every single one of these RDSH, and the same agent will reside in the Win10 VM. And these agents will be responsible to connect directly to the connection broker that we saw earlier in the resource group for the RDMI. I also want to point out that when you create an RDSH on Azure, let's see the network security group for that one, it will automatically create an inbound security rule with a 3389 port open. This allows people to connect to the RDP, the RDSH from outside so they can manage it. If you look at a typical RDMI, RDSH connected to the RDMI environment, you can see that we don't need this inbound security rule anymore. And this RDSH is not in any way in the same network as the RDMI because the RDMIs are non-domain joined. They are sitting in Azure as app services. So you don't need any kind of inbound security rule for those PaaS services to talk to the RDSH. The only thing that we need for this RDSH would be the outbound security rule enabled on port 443, which is a standard port. And so we have gotten rid of this security loophole wherein you have the inbound port open, at least for RDMI. If you still want to go ahead and open a management session to the RDSH, you would still need a 3389, but that does not need to be open for our RDMI infrastructure to talk to the virtual machine and deliver remote apps and remote desktops to the users. Now, I want to show you how the Azure AD MFA can be leveraged for RDMI infrastructure. In the same Azure subscription, I have Azure Active Directory set up with MFA for my set of users. And it's a very simple setup. It's not very complicated. You just need to navigate to the users part of the Azure Active Directory, and you can see that I have a bunch of users here. And I have enabled, if you click on the multi-factor auth here, it will, okay, it didn't open the page there. It will open a page showing you all the users that are part of this particular deployment, and also give you information on whether multi-factor auth is enabled or not for them. In this case, I have not had it enabled for any user except the 13, user RDS PT user 13. That's the only thing that this is enforced for. And the other thing that you need to do to set up MFA is you need to go to the profile for this particular user and set a phone number for that particular user on the profile. So apart from that, you don't need anything to be done on the RDMI. You don't need to do any kind of sync. When the user logs in, you should be able to notice that the MFA is going to be called automatically. So let's try doing that. I have got the, I'm going to be using the HTML5 client that David showed on Tuesday to access my remote apps and remote desktops on the RDMI deployment. And I am going to sign in with the user that has got the AAD MFA set up. And now it should get me, give me some kind of information that, oops. That MFA is set up, and it's going to contact me with an SMS because that's what I set up to do. And I'm going to put in the code, and now I should be able to access my remote resources that's been published to me in the RDMI interface deployment. So it's going to be loading pretty fast after now. And you can see that I have got a session desktop here that's been published to me. Now I can just continue with my work that I've left earlier and sign off. And you can do all of these things, as Clark mentioned, on an Airport console. You don't need to worry about security because MFA was installed and we used it. The other demo that I'm going to be showing is accessing your remote app and remote desktops using our Windows desktop client. So I just launched my Windows desktop client, and I need to subscribe to the feed that was given to me by my admin on the RDMI deployment. So here I put in the feed URL, and then I say subscribe, and immediately it should be showing me AAD authentication window. And you do recall that we don't have any kind of MFA set up for any other user other than the 1.3 user, and it's trying to talk to AAD right now, I guess. But anyway, in this case, it should not have thrown me an MFA if I signed in with a user that does not need the MFA. So it did load, so let's try that out. There you go. It did not ask me for any other challenge other than just my username and password. And this particular user, which is user 1.2, did not has a remote app as well as a remote desktop that are published to him. And if you click on the session desktop icon, it should load a Windows 10 VM, and that's the same Windows 10 VM that we saw earlier in the resource group for this particular Azure subscription and user. And from here, you can do all your client-related apps and continue your work. Now, if I had only a remote app, and in this case, I do have another remote app, I can launch that. And this is actually coming from the RDSH that we saw earlier again. So you can have both a remote app as well as a remote desktop published to a user, and it's coming from totally different collections or host pools, as we call it. Right? So you can see that it was very easy to set up an AAD MFA. The VMs were all isolated. They were not in any way connected by network to the RDMI, and how easy it was for the user to have the same experience as they did with RDS 2016, but also leverage all the security that AAD provides. Hand it back to Clark now.
All right, thank you, Pavitra. Yeah, that's pretty cool stuff. We got a lot of stuff working now already, so it's very exciting times around our group. Now, RDS has always been a platform, and that is no different with RDMI. We consider it a continuation of our strategy of building a platform that all of our partners can build on top of and extend and add value to. And we're actually going to make that even easier now. So we have a PowerShell module, and in addition to that, we have a REST API. And as it turns out, our PowerShell module talks to our REST API, so it's kind of a nice chance for us to test everything out end to end from an admin point of view. But what this allows is our third-party ecosystem now can develop apps, scripts, and services either using the PowerShell or talking directly to our REST API, if they choose to do that. Examples of the kinds of things that we expect and are encouraging partners to develop would include deployment automation, scaling of the session host, and deployment of the session host, image management, just general management GUIs and so forth. So there's lots of opportunities here for our rich partner ecosystem to take advantage of this new platform that's so much more secure, so much easier to deploy. So I'm going to bring Pavitra up one last time here, and she's going to show you a demonstration of a management GUI that's been developed by one of our partners using the REST API.
Okay. All right. So before we go into the management GUI that has been built by our partner, I want to show you that we have a rich set of PowerShell commandlets that we are going to be delivering alongside RDMI. And in this case, what I have done is I have just imported the module. I've set the context to say, hey, what is the URL that I have to be using for this PowerShell module? So I've just set the context. I have authenticated myself against the Azure AD, and then I am inside the deployment, and I can use all the PowerShell commandlets to actually access resources and manage it through this. So one such commandlet that I have got here executed is the get RDS tenant. What it essentially does is it gives you the list of tenants that are associated and have been deployed on this particular deployment. When we talk about tenants here, remember the Azure subscription that I showed you, which was very different from the RDMI infrastructure subscription. Now that is considered an RDS tenant here because that has its own AAD tenant ID, and it's a completely different network with its own set of VMs. So we have four such deployments, four such RDS tenants here. One is Montoya C, the RDS TP0C and tenant 1, and so on. Each of them have their own Azure tenant, Azure Active Directory tenant ID. So they are all distinctive, either branch offices or franchisees, or if you're a partner, then your own end customers. So they are all completely different tenants here. And we are accessing all these things using the PowerShell commandlet. One of our partners, the PeopleTech Group, they decided to take these and convert that into something that they can add value as a service for. So instead of PowerShell commandlets, quite a lot of admins like to use the management UX, graphical UX. So they built a management graphical UX using our PowerShell commandlet first, and then started using the REST APIs because that was equally rich. So the RDMI supports REST APIs as well as PowerShell commandlets that partners can use to manage and administer on a daily basis. So here, if you see, I have got this connected already to the RDMI infrastructure that we saw earlier. I've just given a name to it because you can have multiple deployments. And we should be having a set of tenants here, and we can access all the tenants and all the information that earlier that we could see using the PowerShell commandlets. It should all be accessible here. And you don't need to stop with just management UX. There are multiple ways of extending our infrastructure. One such thing is the new diagnostic role that Clark was talking about. He mentioned that this role will be useful in troubleshooting. So our partners can use the REST APIs to get all the information that the diagnostic roles are keeping, and they can have visualization added on it, they can have alerts added on it, and all sorts of things that will help manage the RDMI infrastructure and the tenants on a day-to-day basis. Thank you.
All right, thank you, Pavitra. Okay, so we got a lot of cool stuff coming here, and hopefully what's going through your mind is when can I get this stuff, right? So we have plans for a public preview starting just after the first of the year, when you'll be able to access bits for the first time. And then we plan to have general availability of the first version of RDMI in the Redstone 4, RS4 timeframe. And after that, we plan to synchronize with the Redstone releases. If you're not familiar with Redstone, that's the Windows 10 release cycle where they ship a new version each 6 months, and we're going to get on that same train. So we'll put the first one out at RS4, and then after that, we'll be synchronized. So V2 will come out in the fall with RS5, V3 next spring, the following spring, etc. Now, one point I want to make sure I land with everybody is that RDS 2016 is the product you've got out there today. It works fantastically in Azure. We made a lot of improvements that I showed you earlier. And there's no reason to stop deploying those guys right now, because there's a very simple migration path from RDS 2016 deployments to this modern infrastructure. Because the session host environments are really where you spend a lot of your time setting up, right? Getting those apps installed, creating those images, and so forth. All of that still applies to this. You can take an RDS 2016 deployment, you can stand up a modern infrastructure next to it in a completely different, as we've talked about, subscription and so forth. You can get those agents installed on those session hosts in the 2016 deployment and direct them at RDMI, and off you go. It's as simple as that. So there's no reason to slow down. Keep deploying, and there'll be a nice migration path for you as we get this out in the near future. All right, I want to draw your attention to a few sessions that happened earlier in the week that I think would be valuable, I hope will be valuable to you. We had a general session on RDS and upcoming innovations, including much more content on the clients that are under development right now. There was a session earlier on Azure Files where we talked about the future integration with with Active Directory and being able to use Active Directory ACLs. And that's the thing that I said earlier is going to support our user profile disks on a PAS file server, right? And there was also a session on Azure Active Directory domain services and the new features there and that are coming. Okay. Just to summarize, I know this is a lot of material, and so I want to try to bring you back to the key points here. First of all, we've refactored the RDS infrastructure components as .NET Core Web Services, so now you can deploy your RD Web, Gateway, and Broker as Azure App Services, significantly reducing the management of those services now. We've also introduced that diagnostic service that's going to simplify troubleshooting. We've now integrated with Azure Active Directory authentication, so you can take advantage of all these great security features that are being developed for Azure Active Directory. We've implemented a reverse connect so that there are no inbound ports required on the session host environment. You can have a completely locked down environment where the applications and the data live. All we need is a 443 outbound, right? We've introduced multi-tenancy. So now I can deploy one RDMI infrastructure deployment and have many tenants that are supported by that infrastructure. And those tenants can be under different Azure Active Directories. They can have different AD structures. They can have VPN connections back to different corp nets, right? It's a great solution for our hosting partners in particular, but we've also talked to many enterprise customers who love this idea of this feature because they're big enough, maybe, that they have different domains and different subsidiaries and so forth, that they essentially can have a central IT group now that works like a hosting partner essentially for the whole broader corporation. And in the tradition of RDS, it will be an extensible platform. We're going to provide both our traditional PowerShell interface, but also a REST API. And that should continue to enable this rich ecosystem of partners that we have out there extending RDS today. All right, so please, if you get a chance, do fill out the evaluation. It's super helpful for us and helps us tailor our talks and make these more productive and more valuable for you. So thank you very much. We'll take questions now. Okay, if you have any questions, if you could use the microphones, please. So I have a gentleman out here.
Sure, quick question. If your whole infrastructure is on-premise, are you still going to be able to use Azure Active Directory to get MFA and CA? So if you have the session host and the gateway and everything on-prem, are you still going to be able to use Azure ID?
Yes, so the question was, if he has his deployment on premises, will he still be able to use the MFA and so forth? Yes, if you're authenticating against Azure Active Directory, regardless of where your deployment is, you will be able to take advantage of all those security features in Azure Active Directory.
Perfect, thank you.
Sure. So I had a question here. Do you have to use Azure Active Directory? In the first version that we're releasing, the answer is yes. Okay, now we do have a way to do this in the future using ADFS instead. We just need a source for tokens, basically. And that has to either be Azure Active Directory and eventually ADFS. Okay? Yeah.
Hello. When you work with RDS 2016 on-premise, is it going to be, can you use your new project Honolulu?
I'm sorry, I missed the last part of that.
Can you use your new project Honolulu to manage
the new product Honolulu with an RDS 2016 deployment?
On-premise deployment. Can you?
Yeah, that's a good question for Pavitra. I don't know the answer to that.
So are you talking about managing it or managing just the VMs on the Project Honolulu for 2016?
Manage your deployment, like you can use your server manager now on 2012 R2.
We are looking at that.
But can
Initially,
you now?
we will be onboarding Project Honolulu to deploy and manage the RDMI deployments. But we are definitely looking and making sure that we have something for 2016 also. Even Project Honolulu has got the same feedback. They want, I mean, there have been a few customers who have asked them to have RDS roles and deployments being managed to that. So we are working on them with them on that.
And another question. You stated that when you use your session host and PaaS, there were no ports open. So how do you mount your user profile disk? Is that also through the WebSocket or?
No. So the question was, if you have no inbound ports open on that session host environment, how do you mount the user profile disk onto the session host? So the file share where the user profile disks live, that has to be in the same environment as the session hosts.
Okay.
So the inbound port is not about the firewall on the server itself. It's about the general firewall on the network security group for the whole resource group and deployment, right, of the session hosts.
Thank you.
Okay? Yeah.
Quick question here.
Yeah.
So what's the story with RDP over UDP in RDMI? I see there's only TCP 443 outbound. Like, does that still work, or is that tunneled through that connection? Like, how does that work?
Yeah, that's a great question. So the question was, what about UDP, the UDP connection that we support today with RDP10 and with these WebSocket connections, will it be tunneled? That is our long-term plan. I believe for V1 that won't be supported, but it'll come very quickly after that, probably in V2. Okay?
Thank you.
Sure.
Yeah, with this new architecture, if you have your session host on-prem and you start an RDP connection, is the RDP connection going straight from your client to the session host, or is it going over the internet to Azure and back to your infrastructure?
Yeah, that's a great question too. So what he's saying is I think what you're saying is if the client and the session hosts are both on-prem, but the modern infrastructure has been deployed up in Azure, does it have to go up to Azure and back, or can it connect directly? In the current implementation we have for our internal preview, you have to go up and back. We are discussing how we might be able to have a peer-to-peer connection in that case, where we detect the case where the client and the session hosts are on the same network, essentially. So stay tuned.
Okay.
Yeah.
Piggybacking a little bit on that question, how do you handle, let's say you have a global hybrids setup where all your host and VDI clients are on-premise, and you have everything else running in Azure? How would you sort of handle the latency you will get going over the cloud and across the world and so forth?
Yeah. So the question, I'll rephrase it and make sure I understand, is if you've got a number of facilities, let's say around the world, where your session hosts live and maybe your clients live, and you're connecting up through a RDMI deployment up in Azure, how do you make sure the latencies are kept under control? Yeah, and so for V1, we're not supporting a geo-distributed deployment yet, but it is something we plan for the future, where you can have your RDMI distributed geographically, and then the broker, when it does its load balancing, will be smart enough to figure out the closest gateways to the client and the closest session hosts to the client. Does that make sense?
Yes. Does that also mean that you can have gateways in different locations in Azure?
Eventually, yeah. That's when we get to that geo-distributed deployment, we will support that. For this first version that's coming out in the spring, it will be geocentric, if you will. Yeah. Anybody else? Oh, sorry.
Okay, one thing my organization wants is to be able to measure how many users are using the system. So who's logging in, when are they logging in, how long are they staying, how often are they coming back? Can I use the new diagnostic service to pull that kind of information out? Because currently I have a trigger set up in the database that fires off a records on their table. Right. So I can kind of archive that. But it'd be nice if I had to do something that was more supported to get the same kind of information back.
Right. So this is something that Pavithar's been looking at, actually, so maybe I'll let you answer this. Can you repeat his question?
Yeah, so your question is, can you use the diagnostic system to retrieve user activity, and so that you can monitor users and what it is that they're accessing? Initially, that is exactly what it is that we want to use the diagnostic system for. It will be tracking admin activity and user activity, and you will be able to get all the sessions, how long they have been on the VM, what VM were they using, if anything went wrong, what exactly went wrong. If you want to do any kind of app-related troubleshooting, that will not be included in the diagnostic system. It'll only be giving you information on up until the session host. So it will still give you information on how long the user was and what kind of information was it that they were using and how the UPD looked, all of that. But it won't give you information on if you're using a 2-level or 3-level app, if anything in the app went wrong or any of those things. But yes, you can use that. That is still under conversation right now.
Can
but
you repeat that?
Sorry, the question was what kind of retention are we looking at for the diagnostic information? Since all this diagnostic information actually lives in the admin's database, they are welcome to go and delete it whenever they want to. We are not going to be doing any kind of automated delete in version 1. Yeah, and depending on what kind of purpose you're using it for and how far back you want to actually access it, you can choose to have your own retention policy.
Yeah.
Hi, Clark. 2 questions. The first question, with this, the multi-tenancy ability, will the web role be able to be customized per deployment?
So the question was, with the new multi-tenancy, will the web role be able to be customized per deployment? So yes, but let me give you a caveat there. The web role is different in modern infrastructure than in 2016. So there's no web interface that you go to. There's only a feed. And so what we expect, this is another area where we assume there'll be lots of third-party innovation. There'll be web portals and what we call aggregation portals set up in front of this deployment, where they take our feed and display icons, right, from the RDMI deployment, but maybe they'll also have PaaS, other SaaS apps being shown in the same portal, maybe access to data and so forth. And we know we have quite a set of partners who are already building these types of aggregation portals, okay? And those are all typically customizable, yeah.
Thank you. And the second question, with the new current branch for Windows Server 1709 and the new release cadence being core only, how are you going to be able to innovate on the session host technology?
Great question. So the question was, with the new current branch for business releases for server core, how are we going to be able to continue to innovate on the session host when the session host needs a GUI? The answer to that is we understand that problem, we're working on it, and stay tuned. We'll have we'll have more to talk in the future about that. Yeah, join the Insider program if you want to get early information on that, okay? Can't tell you any more than that, or Scott will fire me. Any other questions? Greg.
Hey, Clark. As far as provisioning of session hosts like 10, is that on the roadmap too, or are you just doing that?
Okay, so the question was provisioning. Is that on our roadmap, or is that going to be left up to the customer or the partner? For V1, certainly. I think, you know, the way I would say this more generally, and this provisioning is just one of probably many examples, we're going to kind of see, once we get this platform out there, where our partners go and where they innovate and what kind of feedback we get from the customers to try to figure out where we want to extend the platform and add more functionality and where we want to continue to allow, or not allow, but encourage partners to have a role there. So provisioning is certainly one of those things that we've talked about. Right now, it's kind of in our list of this is what we expect our partners to do, right? We want to make sure we get the basic plumbing in place, the multi-tenancy, the integration into Azure, Active Directory, and so on. Once all that stuff is in place, we think we want to allow that innovation around that, right, for things like provisioning and so forth.
To add on to that, with the diagnostics, can you get metrics out of that that will allow you to do that information? Instead of stopping
Yeah, so the question was, will partners and customers be able to use the diagnostics information to maybe make more dynamic decisions about provisioning and scaling? Certainly that'll be one of the pieces of information that's available to you to monitor that. And I will say that in V2, one of the features that we are planning on extending the platform is starting to provide some basic scaling there, because we know that's a big issue in Azure, right? As I said earlier, in order to really take advantage of Azure, we've got to take advantage of its amazing elasticity, right? And that means scaling up and scaling down, or scaling out and scaling in those session host VMs. We've got it nailed now on the infrastructure with the PaaS services, and now we've got to make sure that that's going to be an easy task on the session hosts. Okay?
I would like to just add one more to that. We are right now, at least for V1, looking at diagnostic roles being used for historical purposes. So you go back, you look at what the problem was, or you go and have some kind of reporting on it. If you want to have any kind of live action wherein you are constantly polling or trying to get some kind of VM status, we will have APIs for that. So you will have your own scripts or algorithms that will use these APIs and get information on the VM and then do your scaling. It'll be at the infrastructure level, because all APIs go to the infrastructure, nothing talks to the agent directly.
Any other questions? Yeah.
What will happen to the user sessions and downscaling session hosts?
Yeah, I think your question was, what will happen to the user sessions when we're downscaling session hosts? Yeah, that problem, the problems around that still exist in this world, right? Because that's another problem we're working on kind of longer term. Things like migrating sessions to other session hosts. So for this first release, certainly, you'll still have the same tools you've got today, putting a session host in drain mode, and eventually potentially kicking users off and asking them to log back in and those sorts of things, yeah. Yeah, in the back.
So I'm currently on-prem with everything from RDS, with some of the requirements of going through a web application proxy as well as giving local access to stuff.
Yep.
I came here looking for some direction on how to get into Azure. So from a direction standpoint, what can you provide for how to get there from implementation as well as from licensing and consumption-based?
Okay. So I think the question was, he's got an on-prem deployment right now, and he's looking for sort of some guidance on how to move into Azure, both from technical and from licensing, it sounds like. Okay? So with RDS 2016, we've got a ton of resources out there right now on how to deploy in Azure. We've got documentation, we have ARM templates that will automate the deployment and so forth. The licensing for RDS really doesn't change much. The only caveat there is that we only support per user licensing in the cloud. We don't support per device. Okay? With RDMI, obviously it's a brand new thing. We've got deployment scripts and so forth, but we're still working on documentation. By the time we get to the public preview, we'll certainly have initial documents that explain how to deploy in Azure and how to migrate your 2016 deployments over to RDMI. But for now, I would take a look at the current documentation set that's up there. If you go to aka.ms/RDS, you will land at the top of our documentation tree. If you want to go specifically to Azure, we have another vanity link called aka.ms/RDS on Azure, all one word. And you will find a documentation set.
I did a lot of research. I was trying to figure out how to put it in the cloud, but also to allow access to local resources, such as we use it for giving access to IT management for like VMware, Horizon View centers. So
for your on-prem deployments. Yeah.
Trying to understand that a little better.
Okay, we should probably take that offline, and I can talk to you about some of the options there. Yeah. Okay.
You had mentioned that the diagnostics rule is going to go all the way up to the session host. Is that also going to include onloading and offloading of the UPDs or user profile disks?
Yeah, I think that is true. It includes, yeah.
Okay.
Yeah, the question was, will the diagnostics cover, in addition to the end-to-end connection, but will it also cover the loading and unloading of the user profile disks? And the answer is yes, it will cover that as well. Yes?
What if I have a 2012 structure and I want to migrate to the Azure infrastructure?
So he's got a 2012 or 2012 R2.
2012 R2
Yeah.
infrastructure.
Okay. Well, the RDMI will support 2012 R2 session host as well as 2016 session host. So the migration story I talked about earlier applies to 2012 R2. So you have the choice. You can either upgrade your 2012 R2 system first to 2016 and then integrate it into an RDMI deployment, or you could skip that middle step and go right to RDMI and then integrate your 2012 R2 session host into the RDMI by installing the agents like I mentioned earlier.
Will the RDS users be included in the Azure Active Directory licenses, like the CHP wants to use roles over there?
So I think what you were asking is, will the RDS licenses be included in Azure Active Directory like other products? I'll generalize, I think, what you said. That is something we're definitely looking at. So this kind of gets back to the earlier question about session host. Stay tuned. I can't really talk too much more about it, but obviously it's kind of a trend inside of Microsoft now to try to use Azure Active Directory for licensing purposes. So we're certainly looking at that. Azure Active, yeah, the question was, do you need Azure Active Directory Premium to use this functionality? The basic RDMI won't require Premium. Some of the features that you want to turn on, like I actually don't know. I think Premium is required for MFA and some of those security features,
and
right?
conditional access, both of them require AED Premium, but
Yeah.
just normal AED without any of those things will work.
Yeah. Any other questions? Oh, sorry.
Thank you, Clark.
Yeah.
One thing I noticed missing from the slide was the RD licensing role. How
Yep.
am I going to pay you?
Yeah, you caught me. Sorry. Well, this kind of gets back to the earlier gentleman's question about, are we looking at AAD for our RD licensing? The answer is yes, we are looking at that. And there's enough sort of up in the air there that we're still investigating that we decided to just kind of like sort of not talk about that at this session. So what I would say is worst case scenario, and I do mean worst case, is you'd have to stand up a license server in every one of those tenant environments, a traditional classic 2016 license server in those environments. But we're hoping and working hard to make that not the case. Okay? Yeah.
Now, I saw that the RDVH role was going away.
Yes.
Is there a future for the remote FX video adapter?
The remote FX video adapter, if RDVH is going away, what's going to happen to the the remote FX video adapter? Scott, can you answer that? Good luck with this.
I'll just hold it. So generally speaking, the technologies that we call remote FX, and I think you're talking specifically about some of the GPU sharing technologies, those will continue to function. The new technology we introduced in 2016, discrete device assignment, you'll be able to assign a discrete GPU to a VDI instance or to a session-based environment. Remote FX, the proxy model that you're talking about, there's some newer generation GPU partitioning and GPU paravirtualization technologies that are in development within the Windows organization. And we hope to have more information for you about how those things, when they'll light up, how they'll be supported. But the plan is for those technologies that are being built out of the graphics team to be supported in VDI, generally speaking. So the RDS team isn't making investments in our own specific GPU sharing technologies anymore. We're leveraging the industry standards that are emerging and the work that the Windows team is doing generally around graphics pair virtualization and graphics partitioning and discrete device assignment. So you're seeing that migration of that work going to Hyper-V and going to the graphics team within Windows. So there's some great things happening there. But the traditional pair virtualization with RemoteFX through Hyper-V, that wouldn't work if you eliminated the RDVH role. Okay?
Thank you.
Okay, I think we're going to have to call it now. I really appreciate you all sticking around and asking tons of great questions, so we'll see you again soon.